Hey there, my name is Priyanshanak, and today I'll be demonstrating bump and normal mapping in OpenGL using my three little spheres over here for simple meshes to properly demonstrate my tangent space normal mapping pipeline. This geometry was specifically chosen because it's much more easier to see visible detail purely from shading instead of mesh complexity. So my shader still uses a simple bling Phong shader for diffusion specular highlight. Um, What's new is that I have this toggle here that allows me to trigger the normal map. And as you can see, the spheres now have a brick, a rocky, and a wooden texture applied onto them. So they go from being completely smooth to following like high frequency detail with proper geometry. And we can tweak the normal strength to see it going from flat to extremely strong like this. In addition, I have a little debug control over here, which allows me to compute the final world space normals as RGB. So the red, the green, and the blue represent the XYZ coordinates specifically. And as you can see, the tangents are being applied like this. So this is how the variation is introduced in normal map. And you can also turn this off. This is how the tangent calculation is happening aside from the shader. So a little bit of talk about that. What I did is I extended my vertex struct to additionally compute tangents, which is the XYZ part, as well as the handedness, which is simply the sign of the orientation. So the right hand or left hand calculation for the normals. And I do this by computing per triangle tangent accumulation by fetching the vertices of the angles and then computing the detriments over here. I compute both the tangent and bit tangent directly and from orthogonalization so that I'm always receiving the perfect tangent data. And this is just the Grand Schmidt approach for it. What I do is that in my vertex shader, I transform the tangent to world space. I re-orthogonalize it with respect to the given normal. I derive the bit tangent, which is already provided. And then I compute the world space basis matrix, the TBN, like such. Then I supply it to my fragment shader, which when using a normal map, it unpacks it first of all so that it can handle the signs, and then it applies the normal strength, which is just a little tweak trigger you saw over there. I also perform a direct test conversion, which like in regular GL shaders, you don't need to do this. I couldn't find any, so I have to flip the Y axis of them. And then I renormalize it and transform from tangent into world space once again. As you can see this result run here. So we're gonna turn this off and actually see the textures in action. So without the normal map, the textures appear very flat and I can bring the light to orbit around it so you can see it like such. Let's reduce the radius quite a bit and increase the ambience. But now when the normal map is used, now you can see the depth applying to it. So now each of these spheres have a proper geometry, as you can see. So we're gonna bring the light closer and you'll be able to see it much better like from this angle. So what really happens is that normal strength can be allowed to go from completely flat to basically faking geometry without actually having to compute very complex meshes and like compute the more strategic vertices placements. This happens all of that as you see during just the coding phase in the CPU and as well as in here, which makes it a lot more easier to express geometry using shading. So all of this is just supplied from texture, the roughness, the normal mapping, the diffusion, all of this comes from different textures and they're just all combined over here. Speaking of bump mapping, upon my research, bump mapping usually tends to start from like a height. And then what happens is that you compute the height changes across the surface and then you derive the normal mathematically from the gradient that comes up and then the texture will store height instead of direction like like as you can see, this one shows direction. What normal mapping does is that it's just derived version of a bump map, but it just skips that derivation phase and directly stores the normal direction per pixel instead of like having to store the height. So it's basically a pre-computed, more explicit version of bump mapping. And in modern workflows like live textual libraries such as like Polyhaven or Search provide normal maps directly, and height maps are kind of optional. The visual goal is achieved all the same because we can see proper geometry when we look at it from different angles as well. So yeah, in a gist, that is my full demo. I hope you were able to learn something new and have a nice day.